All right, here we go. We're going to click the down arrow here and browse recent documents and open our Axle from last time that we were together. Mark said that he lacked this groove, but I think Liam just got him up to speed. Is that right? Awesome. Does everybody have this? All right. If you look at your drawing here, you'll see that that's all there really is to the upper portion of this. So now what we want to do is we want to create a sketch on this underside here. So right click on that underside and launch a sketch. Launch a sketch. Go normal to it. Choose a circle tool with the center on the origin. And if you consult the diagram, what diameter is the lower portion of this? Yeah. 0.3125 is incorrect. If you look at what that's dimensioning, it's dimensioning that little groove that's in there. We need the whole, the 0.375 is correct. That's 3/8 of an inch. So 3/8 of an inch is the dimension for this lower half of the part, basically. A little less than a half, I guess, only 1 inch. Once you've got that, you can exit the sketch. You will extrude emboss base it blind by the distance 1.5. Because it's just going to go out, boom, 1.5 from there. All right, so what we need to do now is we want to cut that groove that appears right down here somewhere. We're going to have to right click on the front plane in the design tree and launch a sketch and go normal to it. And what you actually might want to do is zoom in a bit on the lower half here, because that's what part we're working on. When we do a revolve, we need to have an axis around which the revolution occurs. And so the first thing we're going to do is we're going to put in a center line, not a line, but a center line. We're going to start the center line tool. We're going to click once on the origin, which is right in the middle of the part, and then drag straight down until, I don't know, you hit the midpoint at the bottom there. So if you look, you'll see on my screen, you see how there are two little yellow boxes right next to my cursor there near the bottom of the screen? So what does that mean when you get the yellow boxes while you're making a sketch? It will apply those relations if you click at that instant. So I'm going to click now, and that applies those relations. Now, what's weird about this, the center line tool is it automatically assumes you're going to draw another line. So you're going to have to hit escape to turn off the center line tool. So everyone should have a center line now that's on the front plane with one end coincident with the origin and the other end coincident with the midpoint of the bottom face, and it should have the vertical relation. So now we've got this center line. What we're going to need to do is draw a rectangle over here on the side and get it oriented properly. That rectangle then, when we go to do the feature, will like essentially pivot around that axis we just drew, that center line. It'll pivot around it, removing material within the rectangle that we do. And so it'll leave that groove, that square cornered groove we have down there. So we're going to do a corner rectangle. We're going to make one point, right about there on the edge of this part. I'm going to pull inward and downward some, maybe like that. So if you look at the screen, you can see basically what I did here. I'm going to click check. So I just put a rectangle right there. Do that. Does everybody have the rectangle? All right, we're going to locate this rectangle. So what information on this drawing do you have about this rectangle you're going to make for that that little cut there? Excellent, Mark. So turn on Smart Dimension, click the upper edge of this and the underside, where the transition occurs between the large and small cylinders. Click a third time over to the side and type in 1 for 1 inch. So we're going to dimension that 1 inch. We all there? Either one will work. You could either do the top line or just that corner. Either one would work because it's a horizontal line. The endpoint is going to be in the same horizontal location as all the other points of the line. What else do we know about this groove? It's 0.0625, but yeah. All right, so then I'm going to click on this top line and this bottom line of it, over to the side, and I'm going to type in the distance 0.0625.
That's 1/16.
That is 1/16. That's exactly right. But yeah, this blue line here, how close or far this blue line is to the center line is currently undefined. What's weird is if you look at the drawing we have, it's not defined by sort of that radius. It's defined by what?
Like how much space is not covered.
Yeah, exactly. It's really the diameter of the cylinder that will be left behind after it's cut. Well, SolidWorks is pretty smart about this. It actually, if you have a center line and you're drawing something beside it, it sort of anticipates that you're going to either mirror it or you're going to rotate it. Somehow it's going to appear on the other side. And so Smart Dimension is already configured to do either that radial distance from the dotted line to the blue line or the diametrical distance from that blue line to where it would be if it reflected around or revolved around. And I'll show you how that works. We still got our Smart Dimension on, yes, everybody? Okay, we're going to click on the center line once, okay? And then we're going to click on that blue edge that's undefined of our little rectangle once. And if you go upward right now, you'll notice if I clicked a third time, and I'm not clicking yet, but if I did click a third time, it would allow me to enter that radius. However, if I move the cursor to the other side of that center line, now it lets me define it diametrically by a diameter. It's anticipating that it would be revolved or reflected around that center line. It's smart. It's a Smart Dimension tool. And so then I can click it now and type in the dimension 0.3125, which is the diameter that's indicated by our drawing. You click check, and that actually pushes that rectangle to where it needs to be so that if it got reflected or revolved around, the interior edge would be 0.3125 from one side of the dotted line to the other side of the dotted line. And now it's black, which means it's fully defined. So we're going to exit this Smart Dimension, and we're going to exit the sketch. Everybody there? All right, less talking, please. Now what we're going to do is while we have it selected in our design tree, and we can make sure we got the features tab selected here, we want to choose revolved cut. And it's pretty darn smart. It figures out that I want to revolve around that center line 360 degrees. It should give you this sort of preview here. Did it give you a preview like this?
Yeah.
Okay. If you didn't, just wait. I'll raise your hand and I'll come to you. But if you click check now on this and you sort of zoom out and scroll to the side, you can see it revolve cut. Okay, we're moving on. All right, so the next thing we need to do here is we need to cut those notches out of the bottom, those two little flat sides, right? And the best way to do that in this case is to use if you look at the very bottom of your drawing, down here, the bottom of your drawing, okay, there's that circle with the 0.3125. That's telling you how far it is from the one flat surface to the other as measured across the bottom, the underside of this thing. So we're actually going to make our sketch right here, if you look up at the screen, right here on this surface. That's where we're going to make this sketch to make those. We'll make a sketch there. And we're going to go normal to it. I'm going to use a corner rectangle, and one corner is going to sit there on that edge, and the other one can go up here somewhere like that. Let's get this one rectangle correct. So let's hit escape to turn off our rectangle tool. We'll turn it back on again later because we're going to be putting a second rectangle over the bottom. This corner here also needs to be coincident with that area, that edge right there. There are two ways to do that. One would be to just drag it until it's in the right spot and then release it. The other way would be to click it, hold down shift, click the circle, and say coincident. Either one makes that point coincident with that circle. So now, since that corner started out coincident with this edge, and this corner has been added coincident with this edge, if I try to move those two, either one of those points, they both stay stuck to the circle. Does yours do that? Next relation we want to do is we want to make sure we cut at least to the upper edge of this circle. So in order to do that, I'm going to make this top line tangent with this circle. I'm going to ask you to see if you can figure out how to make that top line of this box be tangent with this smaller inner circle. I'm going to do it, but I'm not going to talk you through it. If you've done it correctly, you can grab either of these top corners, and if you click and drag them, you'll see that it only lets me move it that point side to side. It does not let me move it up or down, right? Okay. Yours, Mr. Channels, you can't move it at all. It's stuck right there on that edge. But I don't think it's going to matter. I don't. Is there a way to undo it, or doesn't it? Yeah, sure, there is a way to undo it. So here's the deal. Channels has this point also has a relation of coincident with this corner here, with this circle here. Or maybe it's the other top corner. Which corner is it, your right one or your left one? The right one. So it's just like I have. You got that guy right there. Is that right? You got that one that's orange on my. Okay, if you want to get rid of that, and I think you should actually, because I see it's causing problems. We're going to right click on that and just hit delete. Okay, Mark? Yeah. And now it should not force that to be on that outer circle any longer. Anybody else have something weird where it's not looking like mine? Great. All right. Now, the next thing we want to do is we want to smart dimension this. Oh, wait, we can't smart dimension yet. I apologize. I apologize. If you look, you turn off smart dimension by clicking it until it goes back to white. Because we actually, the only dimensions we have are how far we're going to cut this, how far are we going to cut this, looking at the drawing? Correct. And what's the other one dimension we have about this? The 0.3125, which is the distance between this blue line here and an equivalent blue line on another rectangle that's at the bottom. So what we need to do now is put in this second rectangle. It'll be just like this one. One corner will be on the circle. One corner will be out here somewhere. The other corner here on that top line now needs to be made coincident with the circle like that. And the bottom line here needs to be made tangent to that smaller circle. So click this and that, make it tangent. And then when you click check, it should look like this. Now, some of you might have something that looks a little different. If you need assistance, let me know, but don't go talking to your neighbors right now. We can stay focused. We can get through this quickly. So 2 corners coincident, 1 line tangent. Now, this is almost right. But the one thing that we know, looking at our diagram, is that actually this corner here, if you look up at my screen, this top right corner of the bottom rectangle, and this corner here, the bottom right corner of the top rectangle, need to be vertical to each other. Or another way you could do the same thing, if this is how you want to do it, is you can make this line the bottom line of the top rectangle and the top line of the bottom rectangle. You can make those equal. Either one will achieve the same thing. So apply one of those two relations. I'm going to do the side here. I'm going to make this line shift and this line here. I'm going to make them vertical with each other. Well, I don't want to do vertical. Let's do collinear. Collinear. They're in the same line with each other. There we go.
Would the same thing work if you do it with points?
The points you can do vertical. Yeah. The lines you have to make collinear. You can't make well, I guess you can make 2 points collinear, but 2 points are always collinear. So it'll have to be a line and a point, a collinear, or, yeah, something like that. Yeah. All right. Now, what I want you to do at this point is merely escape the sketch by saving your work. You click in the green one, the blue one, and then just click save, and it should save it where you had it. And we'll pick up on this tomorrow. Close the part and close SolidWorks, and then for Tommy here, I will stop the video.